awful trying to find time. Not like you were like before you had some separation because you were able to go outside, right? But now it's like, you work for, like, you get up, you go to your desk in like, or like your laptop, and take a break, kind of like maybe walk around your house, or if you're lucky enough to have a yard or like a place where you can walk around, maybe you do that. Then you go back to the same screen. Then at night you kind of like sit down and binge Netflix and kind of like repeat, 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 repeat. It's like
Yeah,
it
it,
gets
it,
exhausted.
it's exhausting. Honestly, like
Yeah.
I did a few. Well, I did like DEF CON online, and then I did Maker Faire, and then I was like, I'm so done with like online events because I'm just overwhelmed. I'm on my computer 99% of the time now. Like,
Yeah.
Right. It's
You
like
get
on COVID, like, oh, I'm gonna do like this side project that I've been talking for the longest. I'm gonna do
mm,
this and that. Like, I don't have anything to do. And the one thing that I don't want to do after a whole day of work is,
yeah.
be sitting on my computer.
I never
And
wanted to see people so much in my life.
yeah, you deviate. I mean, the thing is, I was doing the KubeCon Europe, and it was hard to concentrate, to be honest, because you're on the computer. So even though that you have the time allocated, you are like, can I let me take a look at this.
That's true too. That is true too. Yeah.
I like, and then you end up like, what did this guy will say?
Yeah. And then I'm like, oh my God. Ahora, now I gotta go watch it on YouTube. Coño.
Exactly. So, but I mean, I mean, I think that the only thing that I've seen so far that it helped me is this short type of events, like like an hour, 20 minutes, where you can focus for that period of time, and that's it. But in conferences, so far it's been hard.
I
So,
agree. I agree.
um,
I prefer this like in small doses. Yeah.
yeah. All right. All right. I think we can get started. It's already 6 p.m. So, all right. So I'll do the intro real quick, and want to welcome everyone to the I think it's the fourth meetup in the South Florida Kubernetes and Cloud Native. So, and today we're gonna be talking about containers and all that crafty stuff that we do with those boxes that no one knows what they do. And for that, we have Juan Lopez today to take it over. So I'm gonna hand it over to you, Juan, and make you host. Are you ready? Oh, I think we lost it for a second. Oh, you're good. Okay.
I'm at,
Let me make you
yeah.
host. You can share your screen and do whatever you need to do.
Okay.
You are a host now. Right? Take it.
All right. Let me see if I can share my screen. Um, there we go. Let me know if what are you seeing right now? Are you seeing my 3,000 windows tabs?
No, I just see one. It's just yeah, please. Actually, I do see one.
Just see the presentation.
Presentation.
I
Okay.
just see one.
Get out of here, man. You're
One have always like an inception of tabs. Like literally the few the lowest number that I seen is about like 1,000.
I'm not gonna show that because I know y'all gonna be making fun of me. So,
Dude, I
Tabs
know
are the new email inbox.
oh my
the
god.
whole server just for the tabs. Just
Right?
All right, get out of here. All right. Well, the idea is that this is not going to be like a normal presentation. I'm not going to be like I'm not going to sit here and tell you like yes I'm the know-it-all expert of containers because that's not real. I just want to kind of share a little bit of my experience and have like a interactive conversation. What about containers and kind of really what they are. At the lower level and have an idea and a little bit of a understanding of how they work, in the low level, and what are the difference between containers and virtual machines, because I think that is a big, apparent a big misconception, and we're talking about it with Angel, and this is how we got to like, hey, do you want to talk about containers? Because apparently there's a lot of people who really are not 100% clear between what a virtual machine is, what a container, and like how they differ, and like all the good stuff. So this is the reason why we came up with this presentation. So the agenda, like I said, where we're going to be talking about, like what are containers, they're kind of like types of containers, the differences between a virtual machine and a container. We're going to go walk through a little demos where we're going to like create a container, kind of like inspect it, see the different layers and whatnot, and then live, if time allows, a little bit of time for Q&A. All right. So a small personal intro, as Angel mentioned, my name is Juan Lopez. I have 10 over years experience in software engineering, in the software development, in really IT. I come from, like a low-level understanding of computers and, systems administration, networking, and all the way to like, being able to write software and deploy apps. Currently, I work at Invista. As a development manager, and you can find me as Juan Lopez all around the web. So let's jump into what a container. So a container is nothing really more than just an isolation, actually a group of allocation and isolation resources that get exposed to a process or an application. That is really it. All right, thank you very much. It's been a pleasure. Goodbye. No, I'm just kidding. In reality, so a container is actually came up to be, as we can see, a set of like I mentioned, allocation in segregated resources. For example, your CPU, your memory, the network access, and actually storage that gets segregated and exposed to an application. So maybe your own application that you're exposing, or maybe a command or some other application that you may have. A container is really not a virtual machine. There's nothing that you're emulating. There's nothing that you're doing especially to create, or you're not exposing your base operating system, as we can see a host operating system. Basically, what we have in the container, we have the host operating system, which is in a lot of the times you either have Windows or Linux. You can also have Solaris, FreeBSD, and we're going to talk about it a little later in terms of what kind of types of containers we have available, and the container runtime, which is what tools the host operating system used to actually do that specific thing. Like I said, isolating and allocating resources to specific applications and resources. So do we have any questions so far? Good. All right.
Good so far. I'm gonna check the chat though.
Okay. I guess we can continue, and Angel, feel free to stop me if you see any questions on the chat or anywhere.
Yeah, I'm checking on YouTube though, and nothing. But as soon as I get a question, I'll.
Okay, sounds good. Thank you very much. All right. So there are different types of containers, and there are a lot of different implementations also, so to speak. The most popular ones are the Linux containers that actually, they were the primordial container technology and de facto standards. And the Linux containers actually work due to two different things in special. There are the kernel namespaces and the C groups. So the kernel namespaces are what actually provided like a segregation, as well as the C groups. And the C groups are stands for control groups. And that's where it actually talks to the kernel of the operating system, providing that layer of allocation and making sure that the process is bound by that specific allocation that it gets provided for a specific process. And the other when Docker started, they started using Linux containers. Then they realized that there was an actually optimal, better, different way to go about their engine and to use a lot of their tool sets that they actually started using. So they came up with their own implementation in that is called a lib container. And there's, like I mentioned, there's a different type of container that comes from the BDS side, which is like a Unix like system that it's called a BDS jail, and the Solaris zone. And even now, Windows have native support for containers. They have their own actual engine supporting Docker. I don't know if you've noticed that for Windows users, they actually have native support for Windows containers in Docker for Windows 10 now. So that's a great thing. Any questions?
No questions so far.
No.
But Juan, can you give me the host back, because there's some more people that wants to join the Zoom, and maybe because you're speaking, you won't be able to see them. So maybe you can make me host again, and I can just.
Oh, sure. Let me see, how can I do that? Stop sharing and go back to. How can I give you
Just
make host? There you go. Okay.
Go ahead, you can share now. Okay, sorry about that.
Okay. No problem. Actually, give me 1 second. 1 second. I'll be right back. Sorry, I needed to turn the fan on because I'm literally melting. The sun is hitting me right there, and this room gets extremely hot. All right. Let's see, application window. There you go. Am I showing the screen? Angel, are you able to see the screen? Yeah, okay, good. Let me, and I just realized I don't even know if I'm showing my camera. Are you even able to see my camera as well?
Yeah, you're good.
Okay. Good. All right. Let's see, give it a perfect. All right. Where is my window? Here it is. All right. So yes, I was saying that Linux, that Windows right now has native support for their containers. They build up their own, container engine that actually is based on the. It's supported by the Hyper-V option for CPUs, which is kind of depending on the engine and implementation that you have. You can either have a segregated usage of a CPU, of a virtual CPU, so to speak, of like a core, or you can have just random access to make your processing and whatnot. So let's go to the actual differences between a virtual machine and a container. And one thing that which is the kind of like the key point that I want you to all to take from this is, the keyword here is emulation. So The emulation is actually what makes a difference for a virtual machine and a container. For containers, we're not emulating anything. We're just segregating in allocating certain, like I said, RAM, CPU, network access, and storage to certain processes, and they kind of like are exposed as a little operating system. So we're going to see that if we're going to create a container, and then we can actually go into the container and type in bash and kind of like type in top to see the current processes that are being executed, and we're going to be able to see all that. But in the end, it's just a short a minimal part of like the host operating system that we're exposing. Whereas on the other side with the virtual machine, we make use of a hypervisor, and the hypervisor is the actual difference that makes this whole thing, because the hypervisor helps emulate an actual operating system and sits on top of the host operating system compared to a container. So a container, it doesn't have a hypervisor, and we actually make use of the host operating system, whereas a virtual machine, we use the hypervisor to emulate certain parts of or everything that is exposed to a machine. So, for example, we can emulate CPU, we can emulate video cards, we can emulate network cards, and everything and anything that gets exposed to that operating system. So, at the end of the day, you have the host operating system. On top sits the hypervisor, and then on top you can actually use your guest operating system. In for the operating system for the guest operating system would be as if it was actually running on its own hardware itself. Right now, with the container and the virtualization technology getting a lot more advanced and better. A lot of people are creating operating systems that are aware or that are geared towards virtualization. So we're going to talk about different starting points for our containers when we go into the demo. Such as Scratch or Alpine versus different versions of Linux and even other operating systems that are able to understand that they're running in a virtualized environment and actually take advantage of different things. All right. So, and also to go a little bit into the virtualization and to understand, because there can be a little bit of ambiguity in terms of whenever we talk about containers, and maybe the a type of virtualization that is at the low OS level, so at the operating system level, and this is known as prior virtualization. So the prior virtualization is I don't know if maybe in many of you have or did use in the old times, maybe 10 years ago, virtual private servers. That was the main offering of a cloud provider, and it was actually kind of like you're renting like your own little server where you could actually install, I don't know, Joomla or Drupal, because that's what we used to use, right?
How dare you?
But yeah, so or we would have our own very complicated VPN tunneling system before the Onion or Thor was created, right? But really the power virtualization uses part of what a container technology or engine would be, but it does kind of expose, or would actually be, it would be able to emulate different resources or like hardware per se. So in those, in a very good example of this is actually OpenVZ, that uses that exposes KVM and QEMU. So KVM is kernel kernel-based virtual machine, and QEMU is a quick emulator. And these two different tools actually combine to offer a very light virtualization. So that's why it's not 100% virtualized. It's not completely emulated, but it offers kind of like a interface so that you're not fully emulating the whole operating system, or you're not using a hypervisor, but you're kind of like emulating some of the resources that you expose. And we also have the other part of the spectrum, which is the full virtualization. So like what we talked about it, we emulate the resources that are exposed to guest operating systems, and this is usually done via the hypervisor. And some of the examples that we have are VirtualBox and VMware, vSphere, and I think another good example of prior virtualization was Parallels. That's a program that's dude, Angel, you need to help me out in here because I'm not a Mac user.
That's actually primarily for Mac to virtualize Windows and other systems. They play really good with Mac, but I think they also available for Windows, I guess. I'm not sure, but I used them Macs before.
Yeah. Maybe you have used Macs? I don't know. I think you haven't used Macs ever in your life.
No.
So yeah, I mean, like I'm sure that those are, a lot of you know that from Virtuoso, I think is the company or that bought Parallels, or that actually make Parallels. So yeah. Let's continue. Does anybody have any questions so far? Let's see any questions right here.
This is not a question, but as Nicolas says on YouTube, that don't forget about Zen, dude.
About Zen?
Yeah. Yeah.
Zen? What's
from Citrix, right? I think that's how Citrix started with Zen. I'm not super familiar with Zen, but I think that's where they come from. And maybe Nicolas, you might want to add a little more, but I think that's from Citrix.
Yeah, maybe I'm blanking out on that one. I'm not sure. Definitely, I'll keep it. Let me take that now because I would like to Zen. I thought you were talking about Zen PHP, the framework. I'm like, what? How did that come from here?
That'll be a question for Aiden.
Yeah. Alrighty, let's continue. So what advantages do we have using containers over virtual machines? One of the biggest ones is actually resource consumption in speed, portability, and adoption. The main one for me really is speed and portability. Right now, resource consumption, we're not as constrained as we used to be before. So it's not like, I don't have 32 gigs of RAM and 2 terabytes of hard disk space on my laptop. That's actually, very common right now. So, but the actual speed and portability that offers using containers is actually what I think has promoted the adoption over any other virtualization technologies that we had before, that we have on the playing field. In terms of speed, since we're not since we're not starting an emulator, we're not starting a hypervisor. In terms of whenever we tell the operating system to actually start and kick up, or whenever we tell a container to actually start and kick up, we don't have to wait for the actual guest operating system to be up and run. There's no guest operating system. Remember, it's just an isolation segregation part of that is actually exposed as a container. In terms of portability, right now you can just create an image and tell AWS or Google Cloud or Azure, this is my image of my application, run it, and you can actually be on the go in no time. the other part of or portability that also goes back to resource consumption speed is actually how containers are created. And we're going to look at that when we go to on the demo. But really, every single time that we give instructions on how we expect our containers or what we tell how create our containers, we're going to be putting layers on top of each other. And this same concept applies not only to Docker or Linux containers, but also OpenVZ. So I definitely suggest you to take a look at that if you want to, with one of the loves of my life, which is Proxmox. If you actually are very interested in knowing more about this, I definitely suggest you to go to Proxmox and support them, because Proxmox is the best, and I'm not getting paid for that. And should this go in here? And my internet's so slow that it's not building. It's not rendering. Anyways, let's go back. All right, so demo time. And for that, I need to kick it back to Angel, because Angel's going to do the demo, right? Just kidding. No.
Actually, while you're setting up for the demo, that I wanted to because that's an interesting. I'd like to know if I'm pretty sure that you're gonna demo probably Docker, right?
I'm sorry, come again?
I'm asking if you're probably gonna demo Docker itself.
Yes, that's what I'm gonna do.
It would be interesting to know that if there is more alternative to Docker. I hear about. And I used it a couple of times just to do some POC like LXE. This Cryo. There is another one from Windows that we were talking about, but I really don't recall the name. Cryo with Podman usually is if we use together, but anything that you want to add there, or any experience other than Docker that you want to share?
Yeah, so right now what I have prepared it's really the a demo of what a Docker container is and the layers of different Docker, or like the different layers of a Docker container. I don't have with me a running Windows computer, so definitely wouldn't be able to show you that. In different other containers, type of containers, we could probably try to get OpenVZ. But I was definitely prepared to go over Docker.
Oh, no, that's fine. I just wanted to know if you have any, if you knew about all the alternatives usually to know if there's anything else other than Docker there. So.
Oh yeah, for sure. Like I said, the what you mentioned, LXC, which are the Linux containers. The other ones are the BDS gels and the Solaris zones. Windows also has their own version of it now. I personally, my work computer is a Windows laptop, and I use the native Windows containers to actually power my Docker container. So everything works fine. We can definitely have for each one of the types of containers, we can definitely have a whole conversation about one of these presentations can be just done for each one of those types. But definitely, we can talk about them in the future.
Oh, there's one that Ubuntu developed that only works in Ubuntu. But only those Ubuntu containers. I'm not sure. It's something start with M, something like that. But anyways, I don't know. I wonder if you have any thoughts on that one, because I heard about it, but that was about it, and I want to know if you stumbled upon it.
Not personally. I have not been able to play around with that though.
No, it's okay.
All right, let's see. It's share my screen. Let's see if I can share the whole screen. Yes. All right. Where is, oh, perfect. It's all the way over here. I'm going to move it down. So, let me see if we can actually have, did clone the one that you mentioned, Angel to see what, the one that we used last time. So let me open this one right here. So that's the one I want to talk about. All right. And I guess this actually goes a lot more in depth into like the different patterns that we can use to actually build containers, you know, with the builder pattern. But in reality, for example, if I go and open this, I tell a Docker file, you know, I go from. In base image, I could actually even, there's an image that is called Scratch. That we can draw from, and this would be our starting point to create a container. Let me see. Hold on. I kind of lost the. I kind of lost my notes. Give me 1 second. All right. Okay, so I'm just going to go with this one. All right. So let's talk about why we're doing this in this Dockerfile. You know, from in Docker for the whenever we're going to start our definition for our Dockerfile, we need to tell it where to start from. A lot of the I don't know, for example, Golang programming languages or runtimes such as Node.js in .NET Core. Actually, you know, they provide now their base images where, you know, we actually expose those runtimes and actual, you know, we're able to compile our applications and then, you know, expose them, you know, package them as their own little nice modules or, you know, images, so to speak. Let me see. So for in this first step, we're telling it that, you know, we're going to pull from Golang, and we're going to pull this tag, which is, you know, the 1.4, and most likely, you know, we're calling this out this tag Alpine, and like I mentioned, Alpine is a version of Linux that is very stripped down to only include a very set of module or like applications that would allow us to run our create our containers and reduce the actual size of a container. If we, for example, we can actually start with a full-blown Ubuntu image that would actually, you know, be extremely big. But, you know, since we're trying to we're not trying to provide, or we don't need to provide a whole operating system or expose the whole operating system. We just need a set of different tools that allow us to compile, for example, in this case, a Golang application. In the run, we use the run command to actually tell it what we want to do. So commands that we want to run on the as part of our layers that build up the image, we're going to go ahead and create a directory, and we can actually add the Git package and the SSH client. Then we're going to change the working directory. We're going to expose the environment variable. Then we're going to copy, and this is a conversation that we had last time, right, Angel? Copy versus add. And do you want to remember what was the kind of like the bulk of our conversation last time?
Yeah, I mean the thing of the copy is that they very close. I'm still at this point a little confused of what the benefits of doing one or the other one, but usually copy is a better approach when, especially when you're using these multi-steps, because you're basically just getting a snapshot of your source into the container. Add usually may leave some linking, which might act a little funky. So that's kind of where copy, it depends on what you're using. Copy is a better choice of, than add, but still a great area for me.
Right, and honestly, to be honest with you, I really don't know what the difference is. And the if you go to the documentation, they tell you that on the actual the documentation says that a copy. Let me make sure, because I was looking at that last time. The copy is the way to go over add. That is something that they recommend.
Yeah, I think that that's what they recommend usually, but sometimes it's a real good area when you use add or copy.
Okay, yeah. So let's continue. We're going. This is a little bit hard.
Yeah, line 19 breaking up.
Yeah, in this one. So from after you expose this layer, this part of the container, actually from here all the way up, then you can actually call this the whatever you have done in the previous layers, and you can copy from the builder, which is you're defining here, to copy whatever it is at this location, and put it in in the current specific working folder, which should be root. Right. Let's see. How about we just go ahead and tell it Docker build.
Yep. Sure. So in the meantime, while you're doing that, something that I like to highlight of why doing multi-step Docker files is because usually when you're building your code, regardless of your code, if it's like a Node.js thing that you need to install package like npm, or even if it's something like Go, Java, .NET, usually you want to use an image as a source that have all the tools that you need. Like in this case, that image from Golang, it has all the tools that you need to build Go, right? So, and that would make a little very, I mean, it's going to be size. It's going to be very big because you're talking about, like, as you can see here, you already are in the over 100 meg, if so. But you don't want to ship that to the production environment. So that's why using multi-step container, multi-step builders actually helps you out to use that big size image to build your code, make sure they have all the tools. And once you finish that, then the result of that, you can move it to a little less verbose image. And usually if the less that the image has, the better when you are in production. So for example, something like you were saying, Juan, at the beginning. So like shipping that container using like Extrash or something like that, that it literally have just the kernel basically to run things. That's better because two things. First, it's very reduced in size, so it's not the same to send over the network a 5 megabyte, 2 megabyte, actually a 10 megabyte container. rather than 100 to 100 megabyte container. And also it's a good thing because you are basically closing all the doors or potential doors for security breach. Like if you have installed things like apt-get, let's just put it in a very simple words. Let's say you have apt-get installed in your container and it's running, you already have a potential security breach because let's face it, at runtimes, you don't need to install anything. So there's no need for you to have any installed tools or anything else that other than just the binary that you're running. Now, I found some of the interesting cases is when we're running code like not compiled code. It's, for example, with Java, not so much, but something like Node.js, right? Where you literally have to have Node running, right? So unless you already test this package from Sate that you can create Node.js as a binary. But other than that, you always have to have at least Node running, which is why you can see that in Docker Hub, Node has these images where are very light that only have the Node binary, but nothing else. But do you have any experience or have you seen like anything else that we can do to maybe optimize those containers a little more? Because we Go is and Go and C is pretty easy. You just compile it, you get the binary and run it in Scratch. And the Scratch is like 5 megabyte image. What is your experience with that?
Little to none, really. I haven't been able to, really haven't been put in a position where I need to reduce drastically the size of my image. Kind of like becomes an issue. But it is definitely an issue when like you mentioned you're trying to, for example, have different locations or geolocate your application, and maybe move it to one registry to another. When you're developing, you have to wait for your for example, in your CI/CD pipeline, you need to wait for that image to build, and the smaller the size, the faster your Docker image is going to be, the faster it's going to upload to different registries, and the faster is going to be the replication between that mesh that they will have. But really, I haven't, to be honest, been or had to deal with that issue before.
Okay. So any for example, for those Node.js developers that are out there, any specific image that you usually use for deploying the Node.js containers, or you use the baseline Alpine?
I personally use the one from NodeSource. I found, yeah, let me see if I can put it in NodeSource. Yeah, so the one from NodeSource, I really like it. They have pretty much everything that I've ever needed. Let's one over here. The size of the image is very nice. Is very good. They offer, I think they do offer Alpine. Let me see. I don't know. I'm not sure if they offer Alpine.
Yeah, it seems to me that they're very data and sensitive based.
Yeah, and the good thing is that they also maintain it. They have different versions. So if you want to use, I think this is the official for the Node Solid, maybe. Let me see. Well, this is the image that I use by default in my personal projects for Node. I don't know if anybody else has a different opinion or has used different ones.
Chris said,
Scott.
yeah,
Go ahead.
that he used the Alpine image as the base. So that's an interesting because like I say, in compiled languages is easier to manage because at the end, like I said, you always get a binary, so you can run it whatever. But I'm very curious, and this is kind of like what I would like to understand more of those scripting languages like Node.js, which I don't know if you've done it before, like making your source like a binary. I think there's a package that does that, but I haven't used it too much to even have an opinion. That's interesting.
Yeah, I just realized I'm trying to install Dive. I wanted to take a look at the actual layers of the of the image, but I think I updated and Dive is not working. I'm trying
to use ASDF, man.
I definitely need to change that. To be honest with you, I keep forgetting. It's just telling me that Dive already exists.
Any questions, or I'm gonna check the chat real quick. So while you're doing that, nothing in YouTube. Nothing over here as well. No questions so far, Juan. Pretty straightforward. You're on mute just in case you're talking.
Thank you. So yes, I was just had to download it again. But you know what? I just realized that I didn't hide. Realized I didn't. I told it to build, and I never tagged it.
Oh.
So this would be a great segue. Angel, why should I tag my images?
So just tag with usually put a prefix. So if you want to put like your Juan Lopez, your name, that would be great. So usually you will not prefix it, but you can just type whatever, and that's fine. And dot. There you go. You have it. Boom.
Oh.
I think you need the latest, right?
What was that?
Oh, is you have to do sudo.
Trying to pull. It's trying to pull from whatever is created already. I don't want it to pull. I wanted to inspect the one that is already there. Come on. The definition of insanity: doing the same thing, expecting different results. Builds and analyzes. Commands.
There's a question on the chat on the YouTube chat. Meantime, so what is scenario would you recommend VMs over containers?
In what scenario do I recommend VMs over containers? Well, it really depends on whether, for example, if your application requires support from a full operating system, right?
Okay.
I'm trying to think about a good example. Let's say that for some reason you have an application, you need to like it. I don't know if that example right now. I was going to say something about Windows, right? Because before you couldn't have a Windows operating system, containerized, but now you do. So that really doesn't with Windows containers.
That's a good question, because containers have been taking so much over this space where it's hard to find a case where a container cannot just run, because even if they say, you know what, you have a heavy computation, right? And you need a lot of resources in one container, which I would never suggest having a container with too many resources. I think at that point, it's more like an application architecture itself. For example, let's say that you have a computation and it requires a lot of, let's say, 8 gig of RAM and 4 cores, right? So yes, the obvious reason will be I just use a VM and run that computation. But in reality, if you can rely on a queuing system, all the part of your architecture, and separate those concerns, you might end up in having maybe, you know, a fleet of like 10, 20 containers doing that job as synchronized by a queue. So
Right.
I think in the VM space, and that's a good question, Bob, is more about, do you have an architecture that is preventing you to take advantage of the container? And if you don't, then probably you can solve that with container. You might need just to change your architecture, application architecture a little bit more to fit that scenario, but most likely you can do it. And even in Kubernetes, which is kind of also part of the topic of the meetup, you can orchestrate those containers in Kubernetes, right? So that's it. So if you need to orchestrate all that many containers, you can do it there. But even there is a new project coming up in Kubernetes. It's not that new, but I mean, it's very new in the sense that now you can run virtual machines in Kubernetes. It's KubeVirt. It's called KubeVirt, where you can now run a virtual machine. Small one, you can run it right there, and you will have what you need. So I think my answer to that would be is your application architecture ready for containers? If it's not, then you might want to, you know, spend the time fixing your application architecture so you can use containers at the full extension.
Right. I would definitely, you know, base the question right around, you know, do you need to emulate anything, right? And also how your application, you know, is packaged. For example, if you want to be able to you know, package an application or and just distribute it, you know, it's a lot easier to do it with containers than, you know, with a virtual machine. Right now, you know, for example, virtual machines in VirtualBox and they have advanced a lot, and a lot of different technologies have collaborated to have kind of like an open standard that everybody should follow, right? To describe, for example, what a CPU, how should an emulated CPU look like? How should I create, you know, hard disk or storage interfaces, and how they should actually, you know, be represented. Um, but it really, you know, in my opinion, would actually boil down to, you know, if you need to package an application and distribute it, or how you, like what Angel mentioned, you know, if you're gonna grab an application, or you know, in terms of what are you trying to do with you know, that is specific, well, like what is the end goal, right? Because one thing that we never talked about was kind of like what one of the accelerators that the virtualization technology had, which was the virtual desktop interfaces, which you know, Citrix actually took over, and you know, they had you know, the run for a long time, where instead of telling people to, no, you need a full-blown computer, or an actual laptop to actually work, you could just like have a thin client that people would actually log into their virtual desktop on the cloud. So you know, the idea would be, you know, in those cases, you know, for sure, you know, the managing of our virtual machines, you know, or managing of a whole fleet of virtual desktops would actually make more sense to use virtual machines compared to containers, because, you know, a lot of people, when you go into a container, and I don't know if you can have a full-blown graphical interface, but most of the times when you are running a container, you actually just expose like that command line interface, through Bash or a shell, but you won't have a full-blown graphical interface as you would with a virtual machine, right? So that'll be a different case.
Yeah, that would be one case. Maybe to Bob's question is that if you try to run a remote desktop, yeah, definitely a virtual machine would be a way to go on that one. Like I said, the you might take a swing at it and run it in a container, and it might work. Especially with this KubeVirt thing. But still, I think that would be a case that I would run in virtual machine.
Right. Yeah. Okay. What was that?
I was saying that you have Dive running, so you might want to.
Yeah. Finally, I was. The funniest thing is I realized I was running on the actual Dive directory instead of the say what where we had the Docker file. So I was just trying to do something silly. All right, but we can see right here that the layers, we're able to have visibility of what layers we have available in that make up of this image, right?
Mhm.
At the end of the day, we have the image details that the whole size, and we have some interesting information about what each of the layers in things that we have exposed to this image contains and in consumes. Then we can actually go each layer and see what is the actual digest the hash, and what things they actually do in terms of what happens in every part of the layer.
So that's actually
See,
interesting. That's a really nice project, and I would encourage everyone to use it when they're building their own containers, because you can basically see a lot of detail of what you having, especially on the bottom side. I think that's dope. The thing that you can see every single path that you have in your container, and you can basically make sure that that you don't have things that you don't need. Um, I think that's something that I really like. Um, so are you exploring the bean folder? Okay, got it.
yeah, good. I just muted myself. Yeah, I was just exploring the bean folder. I was actually collapsing each one of them. Because at the end of the day, like I mentioned, we are actually exposing part of the host operating system,
Mhm.
and then we tell it what different things to use. Right now, everything is pointing out to BusyBox, which is the minimal, or like the what is exposed in Alpine, right? Let's say, for example, on your root, we have the Dockerfile and the actual Go application that is 12 megs. And this is the actual application that we'll be exposing. Another thing that I wanted to show is the fact that if we wanted to
I think your terminal is cut off, so we can.
oh, my bad. You can see there?
Yep.
Perfect. All right. So Docker run rm tag is Juan Lopez. Say what? And I guess I need to give it a name, right? No, it's actually should be IT for interactive.
Yeah.
And I should tell it that I'm going to use shell, right? I actually wanted to execute and go into the
Yeah, we have this issue the other day. I think the version of Docker that you're running does require the dash between the name of the Yeah, dash dash. I don't know why. Maybe that's a lie.
No, I think I'm doing it. I think I'm doing it wrong. Hold on. Let's see. Docker run.
Maybe it's slash bin. First slash bin, first slash.
Hold on. Let me start it.
No, it's interactive.
Uh,
Yeah, just try with the first slash bin, first slash sh. Maybe that's what it's asking. No. Oh.
no. Let's see. What do we have open? Let's see, Redis. So for example, I have Redis running, so I could just do Redis exec bash. So did I? No.
That's the name of Redis.
But I did have Redis. Yes. Oh, let's try Redis. So for example, right now I'm in Redis in the actual container. So who is the bash? Do I have bash? Oh, perfect. Yes. So I can even. Oh, it's not even exposing.
Yes, man.
Top.
You have to go old school. PS minus.
So this is I run Redis as a container instead of having to install the server locally. Same thing with Postgres. I guess I wanted to show just the fact that this actual.
You can do PS. You can do PS minus. Oh, that's a very bare.
It's stripped down.
No, it's very stripped
I think,
down. It's not anything.
yeah, I think it's based on Alpine.
Oh, okay. Wow.
Yeah, but in reality, what I wanted to show is the fact that this is a Docker container that I have the application Redis CLI exposed, and I install the Redis server. So I have I'm able to interact with it in a segregated environment. I did not have to install it on my machine. So, for example, if I exit out of here, if I exit out of here, I don't have Redis CLI. Well, I do have Redis CLI because I installed it on my machine, but I'm not running Redis per se. That's that.
So basically means that you can have multiple versions of Redis running on your computer, each one with for different purpose, and they all might have a completely different version of the config.
Right. Listening. It's listening. Yeah.
So Juan, I don't know how much you still have left, but we are already a little over an hour. So
Oh yeah.
wrap up.
Yeah, for sure.
Awesome.
Let's go back to application window. That was really what I had. I mean, I'm not going to put the slides. The other thing that I had was, if there were any questions, and just thank you. If you have any questions, just like a thank you. A slide, but I don't think there are.
So I mean, if anyone have any Hail Mary, please by all means. But if not, then thank you Juan for taking the time and talking about content and stuff like that. So that was a pretty cool one. And then we might have to. And once again, I want to invite everyone who wants to give a talk. Even though that this is about Kubernetes and cloud native, doesn't mean that it's just about Kubernetes. It's about anything technology around it, because that's what makes cloud native. So, and content is basically one of the biggest pieces on that, because that's basically what Kubernetes runs on top of it. It's just containers, regardless of which one you use. Docker, Kata containers, Cryo, you name it, who cares? It still is a container, so it's the base of it. So I think this is a good one to get back to the fundamentals a little bit. If anyone wants to give a talk, please feel free to contact us, send us a message anywhere, and we'll schedule it. I was basically saying at the beginning of the meetup, the South Florida is a little fairly new meetup, so we're trying to start doing these a little more often as possible. So for that, we need some speakers. So if you're a speaker out there and you like to give a talk, please, please, please join us. So we can, at some point, I would like to see if we can make this, at least twice a month, if possible. We also running another meetup in Spanish in Medellin, and that one is basically weekly. So for those that speak Spanish and want to join, it's on Thursday. There's another meetup. I'll try to put the link of that meetup on the description. So we are like sister meetups between these two. So that's we do a lot of our joint events. But if you're a speaker in English, please feel free. If you're a speaker in Spanish, feel free to also join the other gang. We're happy to have you there and keep giving back to the community. So if nothing more, thank you, Juan. Thank you, Christina and Chris. Cesar, we got Bob and Nicholas online and on YouTube. They were pretty active on the question, so thank you so much. And we'll see you most likely in 3 weeks for the English one. So I'm gonna talk about serverless in Kubernetes. So I'm gonna give that talk in Spanish on Thursday, and I'll be back in Spanish to talk about serverless in Kubernetes. All right, guys and girls, thank you so much, and see you in about 2 weeks. Hopefully we can do it in 2. All right.
Thank you guys. Have a good one. Bye.
Later. Bye.